The idea of extraterrestrial beings hiding in Earth's oceans might seem like something out of science fiction, but when you dive into the topic, it's not as far-fetched as it seems. Covering approximately 71% of the Earth's surface, our oceans are vast, mysterious, and largely unexplored. In fact, more than 80% of the ocean remains unmapped and unobserved. This immense unexplored terrain, with its immense pressure, cold temperatures, and lack of light, would be inhospitable to us, but could it be a refuge for beings with advanced technology? The depths of our oceans could provide perfect camouflage, allowing extraterrestrial visitors to study us from afar, unobserved, unreachable, and undisturbed. Imagine the technology required to withstand the crushing pressures of the deep sea, to navigate in complete darkness, and to remain hidden from our most advanced detection methods. Such technology would surely be beyond our current capabilities, but not necessarily beyond an advanced extraterrestrial civilization. Interestingly, there have been numerous reports and sightings that might lend credence to this idea. One of the most famous cases is the USO, Unidentified Submersible Object, sighting by the USS Trepang in 1971, where crew members reportedly observed an unknown object rising out of the water and captured it on film. Many other naval personnel and civilians have reported seeing strange objects entering or emerging from the sea, behaving in ways that defy conventional explanation. The infamous Puerto Rico sighting in 2013 involved an object that was captured on radar and infrared cameras by Homeland Security, moving in and out of the water at incredible speeds and with maneuvering capabilities that seemed to defy our understanding of physics. Could these sightings be evidence of extraterrestrial visitors using our oceans as hiding places or bases of operation? The lack of concrete evidence makes definitive conclusions impossible. The ocean's depths are one of the last unexplored frontiers on our planet, a place where mysteries abound and where the line between known science and speculative fiction blurs. The possibility that we might share this planet with unseen visitors from beyond the stars adds yet another layer of wonder to the world beneath the waves. Antarctica, the frozen and desolate continent at the southernmost tip of our planet, has been a subject of mystery and fascination for decades. Its extreme isolation, harsh weather conditions, and vast ice-covered landscapes make it a place few humans ever venture. But what if this icy wilderness is not as deserted as we think? What if it could provide the perfect hiding place for extraterrestrial visitors? The idea of aliens in Antarctica is not new and has been the subject of many conspiracy theories and speculative tales. The isolation and extreme conditions of Antarctica would make it an ideal place for an advanced extraterrestrial civilization to establish a base or research station, hidden from human observation. The miles of ice that cover the continent could conceal entrances to subterranean bases, where advanced technology could maintain comfortable living conditions regardless of the frozen wasteland above. What makes this idea more intriguing is the history of UFO sightings and strange phenomena reported in and around Antarctica. For example, during Operation High Jump, a U.S. Navy operation led by Admiral Richard E. Byrd in 1946-47, there were unconfirmed reports of unidentified flying objects observed by the crew. These objects were said to be capable of incredible speeds and maneuvers that defied explanation. In more recent times, satellite imagery has captured anomalies that some believe to be evidence of hidden structures beneath the ice. Some of these images have led to wild speculations about lost civilizations or advanced bases hidden beneath the ice. While most of these can be explained as natural formations or artifacts of the imaging process, they continue to fuel interest and speculation. Additionally, the interest shown by world leaders and influential figures in Antarctica has added to the mystery. Several high-profile visits to the continent have been reported, often shrouded in secrecy, leading to further speculation about what might be hidden there. Could they be visiting concealed bases or meeting with extraterrestrial beings? Clouds, those ever-changing ethereal formations that drift across our skies, may be more than just a beautiful backdrop to our days. What if these clouds could be hiding something more, something extraordinary? The notion that extraterrestrial beings could be concealed among the clouds seems fantastical, but the constant movement and ever-changing formations of clouds would make detection incredibly challenging. It's an idea that combines scientific curiosity with imaginative speculation, leading us to wonder if the sky is not as empty as it seems. The concept of aliens hiding in clouds or using them as camouflage is not entirely without precedent. Numerous UFO sightings have described objects that appear to be hiding in or emerging from cloud formations. Some witnesses have reported seeing cloud-like objects that move and behave in ways inconsistent with the natural cloud behavior, leading to theories that these might be craft using clouds as concealment, or even generating artificial clouds to hide within. One of the most famous instances occurred in 1957, when a British Royal Air Force pilot observed a metallic object enveloped in a cloud, moving at high speed and at an altitude that ruled out conventional explanations. The object seemed to generate the cloud around it, perhaps using it as camouflage. More recently, several sightings of strange cloud formations have led to speculations about hidden UFOs. These formations often appear as perfectly round or unusually shaped clouds that don't fit typical meteorological patterns. Some witnesses have reported seeing lights or metallic objects within these strange clouds, fueling theories of hidden extraterrestrial craft. The technological requirements for creating or utilizing clouds as concealment would undoubtedly be beyond our current capabilities, but might be within reach for an advanced extraterrestrial civilization. The ability to create or manipulate clouds would allow them to observe us from above, hidden in plain sight, monitoring without intervening. Of course, skeptics argue that these sightings and reports can be explained as misunderstandings of natural phenomena, optical illusions, or even deliberate hoaxes. Without concrete evidence, the idea of extraterrestrials hiding among the clouds remains speculative and unproven. But I'd prefer to believe in these sightings than not, because I find it more interesting to think we are not alone out here. The Moon, our closest celestial neighbor, has been a source of fascination, inspiration, and mystery for centuries. Its cratered surface, barren landscape, and close proximity to Earth make it a constant presence in our night sky. But could it also be a hiding place for extraterrestrial beings or technology? The idea may seem outlandish, but there are intriguing arguments and sightings that fuel this speculation. Firstly, the Moon's proximity to Earth would make it an ideal observation post for any civilization interested in studying our planet. The dark side of the Moon, perpetually hidden from Earth's view, could theoretically conceal bases or other structures, allowing extraterrestrial visitors to remain undetected. Advanced technology could potentially enable them to live and operate on the Moon's inhospitable surface. The history of strange sightings and unexplained phenomena on the Moon adds to this intrigue. During the Apollo missions, astronauts reported seeing odd flashes of light, inexplicable moving objects, and other phenomena they couldn't easily explain. NASA's transcripts from the Apollo 11 mission contain references to unidentifiable objects observed by the astronauts, leading to endless speculation and debate. One of the most famous cases of potential extraterrestrial activity on the Moon is the so-called shard, an anomalous object captured in lunar orbiter photographs. The object appears to be towering above the Moon's surface, and its nature and origin have never been conclusively explained. Some have suggested it might be an alien structure or artifact. Additionally, the V formation near the crater Oort and other unusual geometric formations on the Moon's surface have led some to speculate about artificial construction. Though many scientists dismiss these as natural geological formations, they continue to be a subject of fascination and debate among those who believe in extraterrestrial involvement. Many UFO sightings on Earth include reports of objects heading towards or coming from the direction of the Moon. Could these be craft traveling to and from a hidden lunar base? In the world of science fiction, cloaking technology is a familiar concept, allowing spaceships and beings to become invisible to the naked eye. But what if this technology isn't just the stuff of imaginative storytelling? What if advanced extraterrestrial civilizations possess the ability to conceal themselves using sophisticated cloaking techniques, rendering them invisible to human observation? Cloaking technology represents the pinnacle of stealth and camouflage, where an object can be hidden from sight by manipulating light or other electromagnetic waves. This could be accomplished by bending light around an object, creating a blind spot where the object becomes invisible. Such a technology would be far beyond our current scientific capabilities, but it may be within reach for a highly advanced extraterrestrial civilization. The idea of aliens using cloaking technology is not new and has been linked to various UFO sightings and encounters. Witnesses have reported objects that appear and disappear abruptly, as if they were phasing in and out of visibility. Some have described seeing partially cloaked objects that seem to shimmer or distort the light around them, akin to the way heat waves distort our perception of distant objects. One of the most well-known incidents involving potential cloaking technology is the Tic Tac UFO sighting reported by US Navy pilots in 2004. The object was described as having an ability to disappear and reappear in different locations, moving in ways that defied conventional understanding of aerodynamics. Some have theorized that these movements could be explained by advanced cloaking or teleportation technology. Other sightings have included reports of objects that seem to cloak themselves by blending seamlessly with their surroundings, becoming indistinguishable from the sky, sea, or landscape. These reports often describe objects that move without making sound and without any visible propulsion system, adding to the mystery and intrigue. The potential implications of advanced cloaking technology are vast. If extraterrestrial beings were utilizing such technology to observe or interact with humanity, it would mean that they could be present without our knowledge, watching and learning from a hidden vantage point. It could explain why, despite numerous sightings and encounters, concrete evidence of extraterrestrial presence remains elusive. Yet the concept continues to captivate our collective imagination, inviting us to ponder the unknown and to consider the extraordinary possibilities that lie beyond our current technological horizon. The thought that we might be observed by hidden eyes, that the universe may be filled with invisible wonders, adds a layer of complexity and wonder to our quest to understand our place in the cosmos. Have you ever gazed at the night sky and wondered if there's intelligent life out there? And if there is, wouldn't it be absolutely fantastic to meet them, perhaps for an intergalactic coffee or just some good old cosmic banter? Well, not so fast. Today we're diving deep into the theories and ideas of why meeting extraterrestrial life might not be the best thing for us. The vastness of our universe is truly mind-boggling. With billions upon billions of stars, many of which have their own planetary systems, the question arises, where is everyone? Why haven't we found signs of intelligent life? Or why haven't they found us? This puzzling conundrum, sometimes referred to as the Fermi paradox, poses the question, if the universe is so big, shouldn't there be evidence of intelligent life out there? Enter the Great Filter theory. This theory offers a possible solution to the Fermi paradox. It suggests that there's a stage or multiple stages in the evolutionary process of life that act as a sort of bottleneck, preventing species from further advancing or even causing them to go extinct. Imagine the path to cosmic intelligence as a series of steps. These steps could include the formation of planets, the emergence of simple life, then complex life, the development of intelligence, and eventually the creation of technology capable of cosmic communication or travel. If every one of these steps was easy and inevitable, our universe should be teeming with life. However, the Great Filter theory posits that one of these steps, or perhaps more than one, is incredibly improbable. It's a filter that prevents most potential life from advancing to the next stage. Now, this theory can be both comforting and unsettling. If the Great Filter is behind us, perhaps in the leap from non-life to life or from simple to complex organisms, then we might be one of the few, if not the only, civilizations that made it through. That would mean the universe is ours to explore with little worry about encountering advanced alien civilizations. On the other hand, if the Great Filter lies ahead of us, it means our civilization is headed towards some insurmountable challenge. This could be anything from self-destruction via war, catastrophic environmental collapse, or any other number of unforeseen challenges that have doomed other civilizations before us. In the realm of interstellar interactions, a fascinating concept emerges, one that reflects past human histories, the dependency paradox. When two civilizations of vastly different technological levels meet, there's a chance that the less advanced society becomes heavily reliant on the superior technology of the more advanced civilization. Drawing parallels from our own history, when indigenous communities encountered technologically advanced colonizers, they were often introduced to new tools, weapons, and methods that, while advantageous, led to a dependency. Traditional skills and techniques passed down through generations were quickly abandoned in favor of the new technology. But this shift came at a cost. These societies became vulnerable, losing autonomy and self-sufficiency. Now let's elevate this scenario to a cosmic scale. If humans were to depend heavily on alien technology, we might experience a profound societal change. The rapid introduction of such superior tech might lead to the abandonment of our own innovative pursuits. Why invent or innovate when technology from a more advanced civilization is readily available? Furthermore, with dependency comes vulnerability. If for any reason the advanced civilization withdraws or restricts access to their technology, the less advanced society, in this case us, might find itself in a precarious situation. Societies, infrastructures, and systems built upon and adapted to the alien technology might collapse or malfunction without it. Additionally, such a dependency could have profound psychological effects. The sense of inferiority, the loss of self-reliance, and the overshadowing of human achievements by alien wonders might lead to a collective identity crisis. Who are we in a universe where our accomplishments seem trivial compared to those of extraterrestrial beings? The universe, vast and teeming with endless possibilities, may harbor civilizations that, should they ever cross our path, might have intentions that are difficult for us to fathom. The intentions of an alien species, especially one that can traverse galaxies and has advanced far beyond our comprehension, are a pressing concern in any potential first contact scenario. When we reflect upon our own history, encounters between societies of differing technological levels rarely ended favorably for the less advanced culture. Often, such meetings were characterized by conquest, resource extraction, or unintentional harm, such as the spread of diseases. If our history is any lesson, it's that the balance of power and intent plays a significant role in the outcomes of first contacts. Now think about a civilization advanced enough to reach our planet from the distant corners of the cosmos. The sheer technological prowess required for interstellar travel would indicate capabilities beyond our understanding. But technology alone doesn't dictate intentions. While it's hopeful to imagine that any society which has achieved such advancements would have also evolved beyond aggression or territorial conquests, we cannot be certain. A civilization might seek resources unique to our world, be it water, minerals, or even something as abstract as information. They might see Earth as a suitable colony, or perhaps a strategic vantage point in a larger cosmic plan. On the more benign side, their intentions could be purely scientific. To them, we might be a curious case study, a species to be observed and documented, much like how we study less developed species on Earth. But even benign intentions can have unintended consequences. An alien civilization might not understand the intricacies and fragilities of our ecosystems, societies, and individuals. It's also worth considering the scenario where they might be escaping some cosmic calamity, or are refugees searching for a new home. In such a case, their desperate situation could make interactions unpredictable. Lastly, their moral and ethical constructs might be entirely different from ours. Concepts of right and wrong, shaped by their unique evolutionary history and societal growth, could vary greatly from human norms. What they might see as an act of kindness or necessity, we might perceive as an act of aggression or vice versa. Thus, the crux of the matter is not just the discovery of extraterrestrial life, but understanding and navigating their intentions, hoping that mutual respect and universal codes of ethics guide our interactions. Imagine for a moment two worlds colliding, not in the astronomical sense, but on the microscopic front. The alien life we imagine often involves technologically advanced beings or massive spaceships, but rarely do we contemplate the minute, unseen life forms they might carry, their microbial companions. Throughout human history, the spread of diseases has profoundly influenced civilizations. When travelers from different continents met, they didn't just exchange cultural and technological ideas. They also unknowingly shared viruses and bacteria. These unintended exchanges led to outbreaks like smallpox in the Americas after European arrival. The native populations, having never been exposed to such diseases, had no immunity. The results were often catastrophic. Now extrapolate this to a galactic scale. Meeting alien life forms might introduce us to entirely new biological systems. These extraterrestrial organisms, whether harmful in their native environment or not, could have unpredictable effects on Earth's biosphere. It's not just about potential pathogens harming us. Humans might have reactions to alien life at the fundamental cellular or molecular level. Proteins, Enzymes or even chemical compounds foreign to our biology might trigger unforeseen responses in our bodies. Conversely, human microbes might pose a threat to them. What's benign to us might be deadly for them. This inter-exchange of biological material might lead to a scenario where both parties unintentionally harm each other despite peaceful intentions. Moreover, these alien microbes, if they find Earth's environment hospitable, might become invasive species. They could outcompete, prey on, or bring diseases to native species, causing ecological imbalances. We've seen the profound effects of introducing non-native species to new ecosystems on Earth. Alien organisms with no natural predators or controls here could proliferate uncontrollably. There's also the aspect of our planet's environment. If these microbes play a role in their planet's atmospheric balance or any other critical environmental process, their introduction to Earth might have large-scale effects on our climate, weather patterns, or even the composition of our atmosphere. Throughout history, different cultures on Earth have experienced dramatic upheavals when encountering another society with vastly different beliefs, technologies, or ways of life. We can look back at instances of first contact between indigenous peoples and technologically advanced explorers as a small-scale model of what could happen on a galactic scale. These meetings have often resulted in misunderstandings, unintended consequences, and even the unintended destruction of one of the cultures. Now let's magnify this scenario to the interstellar scale. Imagine the vast differences that might exist between our human society and an alien civilization that has evolved independently, possibly for millions or even billions of years. The differences in our communication methods, perceptions, emotions, societal norms, and priorities might be insurmountably vast. The sheer act of comprehending and understanding their intentions, philosophies, and technology could be overwhelming, leading to profound cultural shock. We are creatures of habit, shaped by our evolutionary lineage, environmental pressures, and societal structures. Confronting beings who might not share any of these evolutionary or societal histories with us could challenge the very core of our understanding and beliefs. Moreover, their technological advancements could make our most cutting-edge tech look rudimentary in comparison. And just as the indigenous tribes of our world were awestruck and overwhelmed by the technology of explorers, humans might find themselves in a similar position, but on a cosmic scale. This vast difference in technology could lead to a power imbalance. Even if the alien civilization has peaceful intentions, their mere presence and advanced abilities could inadvertently disrupt our societal structures, economies, and technologies. When it comes to the scale of celestial objects, planets in our own solar system provide a sense of familiarity. Jupiter, our neighborhood's heavyweight champion, feels large, but venture beyond our solar system and you'll find planets that make Jupiter look modest. Enter the world of super Jupiters. These are exoplanets, planets located outside our solar system that boast masses exceeding that of Jupiter. Some of them, like HD 100546b, hold up to 13 times Jupiter's mass. The sheer size and volume of these planets are difficult to comprehend. With vast atmospheres primarily composed of hydrogen and helium, their swirling cloud bands and tumultuous weather systems might span wider than entire continents here on Earth. Yet size isn't the only fascinating aspect of these colossal worlds. A subset of these super Jupiters, known as rogue planets, defies conventional understanding of how planets should behave. They do not orbit any star. Instead, these rogue planets wander the vastness of space alone, without a sun to illuminate their skies. Imagine a planet, massive beyond comprehension, drifting in the inky blackness of space, devoid of sunlight. Their existence challenges our traditional notions of planet formation and asks more questions about the diverse ways celestial bodies can come into existence. Moreover, the gravity on these super Jupiters would be intense, many times stronger than what we experience on Earth. This immense gravitational pull can lead to intriguing and bizarre phenomena. For instance, these planets might have layers of metallic hydrogen deep within their interiors, hydrogen compressed under such extreme pressures that it behaves like a metal. In the hunt for extraterrestrial life, these supermassive planets also present new possibilities. While their gas-dominated nature might make them inhospitable for life as we know it, their potential moons, subjected to the planet's strong gravitational forces, could harbor subsurface oceans, kept warm by tidal forces. Such environments could potentially be cradles for life, presenting a scenario where the most massive planets, even in their hostility, could indirectly nurture pockets of life. All in all, super Jupiters embody the wonder and diversity of our universe, challenging our understanding and stretching the limits of what we once thought possible in planetary formation and behavior. In the vast cosmic theater, stars take center stage, illuminating the universe with their brilliance. But among these luminous bodies, a particular group stands out, not just for their light, but their sheer size: the supermassive stars. While our Sun is often considered a standard reference for stellar sizes, it pales in comparison to the behemoths known as supermassive or hypergiant stars. These are not just larger, they are incomprehensibly vast. Stars like Scuti, one of the largest known, extend for more than 1,700 times the Sun's radius. If placed in the center of our solar system, it would engulf the orbits of planets up to and beyond Jupiter. The lives of these hypergiants are turbulent and short-lived, at least in astronomical terms. Born from massive clouds of gas and dust, these stars burn bright but burn out quickly. Their enormous sizes mean they have an abundance of fuel, but they consume it voraciously. Within a few million years, a mere blink in cosmic time, these stars exhaust their fuel and meet dramatic ends. And it's not just their size that's impressive. The internal processes of these stars are equally fascinating. Due to their vast masses, the pressures and temperatures in their cores reach levels unimaginable in smaller stars. These extreme conditions facilitate the fusion of heavier elements, turning hydrogen into helium and progressing through the periodic table, creating elements like oxygen, carbon, and even metals like iron. Yet this grandeur comes at a price. The more massive the star, the more unstable its life. Many supermassive stars undergo periods of intense pulsations, causing them to eject vast amounts of material into space. This constant tumult makes their surfaces boil and roil with massive convective cells, each one many times larger than our entire Sun. Their demise is as spectacular as their lives. Once the fuel in their cores is expended, they can't support their immense gravitational pull, leading to a spectacular supernova explosion. These explosions scatter the heavier elements formed within the star out into space, seeding the universe with the building blocks for new stars, planets, and even life. In the end, the legacy of supermassive stars is twofold. They illuminate the cosmos with their unparalleled brilliance, and in their death throes they give back, ensuring the cycle of stellar birth and rebirth continues. In their enormity and intensity, they embody the dynamic, ever-evolving nature of the universe. Imagine a region in space where gravity pulls so much that even light can't escape its grasp. That's the essence of a black hole. But beyond the standard black holes, there are entities so massive and awe-inspiring that they defy comprehension. The supermassive black holes. These cosmic giants are often found at the centers of galaxies, including our own Milky Way. Unlike stellar black holes, which form from the remnants of massive stars, supermassive black holes contain millions to billions of times the mass of our Sun. Their origins are still a subject of debate among astronomers. Some theorize they form from the accretion of masses over eons, while others suggest they might originate from the collapse of immense gas clouds early in the universe's history. The gravitational influence of supermassive black holes is so powerful that they can dictate the dynamics of their host galaxies. Around them swirl accretion disks, vast rings of gas, dust, and other cosmic debris pulled in by the black hole's immense gravitational force. As this material spirals closer to the event horizon, the point of no return, it heats up and emits intense radiation, often observable as quasars, some of the brightest objects in the universe. This intense gravitational pull also influences the paths of stars orbiting near them. Observations of stars at the center of our Milky Way have provided indirect evidence of the presence of a supermassive black hole named Sagittarius A*. These stars whip around at such high velocities that only the presence of a massive, dense object like a supermassive black hole could cause such behavior. Yet for all their might and influence, supermassive black holes remain enigmatic. Their event horizons are shrouded in mystery, beyond which our current understanding of physics breaks down. Within this boundary, all known laws of nature become unpredictable. It's a realm where our current understanding of space and time no longer applies. a true frontier of human knowledge. One of the most groundbreaking discoveries related to these entities was the capturing of the first ever image of a black hole silhouette by the Event Horizon Telescope in 2019. This image, a glowing ring surrounding a dark central region, was a visualization of the supermassive black hole at the heart of the galaxy M87, located 55 million light-years from Earth. The study of supermassive black holes is more than just a quest to understand these mysterious entities. It's a journey to the very edges of our understanding, a probe into the extremes of the universe, and a testament to the insatiable human curiosity about the cosmos. Deep within the vast expanse of the universe lie remnants and echoes of its very beginnings. These ancient signals offer tantalizing glimpses into the earliest moments after the Big Bang, allowing us to piece together the cosmic puzzle of our universe's infancy. When we talk about the universe's ancient echoes, the cosmic microwave background, CMB radiation, stands out prominently. Detected for the first time in 1965, the CMB is a faint glow that fills every corner of the cosmos. Imagine it as the afterglow of the universe's explosive birth, a snapshot of what the universe looked like when it was only 380,000 years old. At this time, the universe was a hot soup of particles, and as it expanded, it cooled down, allowing protons and electrons to combine and form neutral hydrogen atoms. The photons that had been scattered by these free particles could now travel freely through the universe. These very photons are what we detect as the CMB today. The CMB provides a treasure trove of information. Tiny fluctuations or ripples in this radiation, which represent minute differences in temperatures, offer insights into the initial conditions of the universe and the seeds for the formation of galaxies and large-scale structures. These temperature variations are like footprints, indicating regions of varying densities in the early universe. Delving deeper into the ancient cosmos, we find relics like population the 3 stars. While no direct observation of these first-generation stars has been made, they are believed to have formed a few 100 million years after the Big Bang. Composed almost entirely of hydrogen and helium, these behemoths were much larger and hotter than stars today, living fast and dying young in spectacular supernovae explosions. The debris from these explosions went on to seed subsequent generations of stars with heavier elements, setting the stage for the complex cosmic dance that led to galaxies, planets, and eventually life. In our quest to understand the universe's origins, we also study the distribution of galaxies, clusters, and cosmic voids. By mapping these vast structures, scientists can trace back the gravitational forces at play in the early universe, shedding light on the mysterious dark matter that binds these cosmic entities together. As our instruments become more advanced and our observations more precise, we edge ever closer to unraveling the secrets of the universe's early days. Each discovery, from the faintest radiation to the most distant celestial object, adds another piece to the intricate tapestry of our cosmic history, reinforcing our connection to the ancient universe and our place within its vastness. In the realm of cosmic phenomena, gravitational waves have emerged as an intriguing subject of study. These ripples in space-time, akin to the ripples created when a stone is thrown into a pond, have revolutionized our understanding of some of the universe's most violent and enigmatic events. Albert Einstein first predicted the existence of gravitational waves in 1915 as a part of his groundbreaking theory of general relativity. Simply put, when massive celestial objects like black holes or neutron stars accelerate or collide, they create waves that propagate at the speed of light through the very fabric of space-time itself. However, due to their incredibly faint nature, it took a century after Einstein's prediction for us to detect them directly. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, made a monumental breakthrough. They observed gravitational waves emanating from the collision of 2 black holes, approximately 1.3 billion light-years away. This detection was not just a testament to human engineering and perseverance, but also opened a completely new window to observe the universe. Instead of just using light, as with telescopes, we now had the capability to listen to the universe's vibrations. With gravitational wave detection, we've gained a powerful tool to study events that were previously hidden from our view. For instance, the merging of neutron stars, which was detected in 2017, not only produced gravitational waves but also emitted light, radio, and gamma rays. By analyzing both gravitational waves and electromagnetic radiation, scientists gathered invaluable information about these stellar smash-ups, the kind of metals produced in the collision, and more insights into the universe's expansion rate. Venus, often dubbed Earth's sister planet because of its similar size and proximity to us, has always been somewhat overshadowed by our red neighbor Mars in the quest for extraterrestrial life. However, a recent discovery has cast a surprisingly bright spotlight onto this scorching, cloud-covered world. For the longest time, Venus was dismissed as a possible haven for life. With surface temperatures hot enough to melt lead and an atmosphere thick with carbon dioxide and clouds of sulfuric acid, it seemed an unlikely place to find any signs of life. But the universe, as it often does, threw a curveball at us. In 2020, scientists made an announcement that caused quite a stir in the astronomical community. They had detected traces of a gas called phosphine in the clouds of Venus. Now, why was this discovery so groundbreaking? Phosphine is a molecule made up of phosphorus and hydrogen. On Earth, this gas is primarily associated with life, produced by bacteria living in oxygen-free environments. The clouds of Venus, where the phosphine was detected, have temperatures and pressures that are somewhat Earth-like compared to the planet's inhospitable surface. This led to the tantalizing possibility: could there be life floating in the Venusian atmosphere? Before jumping to conclusions, researchers meticulously looked for other explanations. Volcanic activity, lightning, and even meteor impacts were considered as potential sources of the phosphine. Yet, none of these scenarios could produce the amount of phosphine that was observed. The instruments and methods used to detect the phosphine underwent rigorous scrutiny, with teams double-checking data and ensuring the signal was genuine. The presence of phosphine doesn't confirm life on Venus, but it does open the door to this exciting possibility. To find more answers, missions to Venus are now being considered with renewed interest. By sending probes to study its atmosphere directly or even to float in the clouds, scientists hope to determine the origin of the phosphine and see if the thick, acidic clouds of our neighboring planet might indeed harbor some form of life. In the grand tapestry of space exploration, the phosphine discovery on Venus reminds us of an essential lesson. Sometimes the search for alien life may lead us in directions we never anticipated. Mars, our captivating neighbor, has always been at the center of mankind's fascination when pondering the existence of extraterrestrial life. With its haunting red landscapes and vast valleys, it's a planet that has inspired countless tales of Martians and space invasions. But recently, some real, tangible clues have emerged from this distant world that could hint at the existence of ancient life. The term organic might conjure up images of green foods or farming practices, but in the realm of chemistry, it simply refers to carbon-based molecules, which are life's building blocks. Such molecules are crucial because all known life forms on Earth are carbon-based. In 2018, the scientific community was abuzz with excitement when the Curiosity rover, NASA's mobile laboratory rolling across Mars, discovered organic molecules preserved in Martian rocks. These rocks, located in an area named Gale Crater, are estimated to be about 3.5 billion years old. This discovery means that at around the same time life was gaining a foothold on Earth, Mars had the ingredients necessary for life. What makes Gale Crater especially interesting is that it's believed to have once contained a lake. With the discovery of these organic molecules, one can't help but imagine a past Mars where water-filled lakes or oceans nurtured early forms of life. However, it's important to note that the presence of organic molecules doesn't directly point to life. Mars is a dynamic planet with a history of volcanic activity. These organic molecules could have been formed by non-biological processes or even delivered from outer space via meteorites. Despite the uncertainty, this discovery adds another layer to Mars's already complex and intriguing story. Scientists, with the help of rovers like Curiosity and future missions, continue to unravel the mysteries of the red planet. Each discovery, each hint of ancient water or molecule, draws us closer to answering that age-old question. Are we alone in the universe? For now, the presence of organic molecules on Mars stands as a testament to the planet's potential to have supported life. As we dive deeper into its secrets, who knows what other revelations await us? Far from the warmth of the sun in the chilling depths of our solar system lie two icy moons that, contrary to their frigid exteriors, might harbor the warmth of life deep within. Enceladus, a glistening moon of Saturn, and Europa, one of Jupiter's largest moons, are more than just frozen celestial bodies. They are worlds of intrigue and promise. At first glance, Enceladus might appear as just another ice-covered sphere, but it hides a dynamic secret beneath its surface. In 2005, the Cassini spacecraft, while exploring Saturn and its moons, witnessed stunning plumes of water vapor and ice particles erupting from the south pole of Enceladus. These geyser-like jets bursting forth into space indicated that beneath its icy shell, Enceladus might be hiding a vast subsurface ocean. Europa, with its cracked, ice-covered surface, tells a similar tale. Observations from various missions and telescopes have provided strong evidence that a massive subsurface ocean, potentially twice the volume of Earth's oceans, exists beneath Europa's icy crust. These observations, coupled with the Moon's induced magnetic field, suggest the presence of a salty, liquid water ocean. But why is the discovery of these oceans significant? Water, as we understand it, is a fundamental ingredient for life. On Earth, where there's water, there's often life. These hidden oceans on Enceladus and Europa offer the tantalizing possibility that, in their warm depths, microbial life, or even more complex organisms, could exist. It's incredible to imagine that in such extreme and distant environments, life might find a way. The potential existence of hydrothermal vents on the ocean floors of these moons further amplifies this possibility. On Earth, hydrothermal vents in our ocean's abyssal depths teem with life. These ecosystems thrive without sunlight, relying instead on the chemicals spewed out by the vents for energy. Could similar vents in the oceans of Enceladus or Europa be home to alien life forms? As technology advances, our gaze turns not just to the distant stars, but also to these icy worlds in our backyard. Future missions to these moons aim to study their oceans more closely, hunting for signs of life or the conditions that might support it. The discovery of these subsurface oceans has reshaped our understanding of where life might exist beyond Earth. It's a compelling reminder that sometimes the most exciting mysteries and potentials for discovery lie just beneath the surface. The TRAPPIST-1 system, discovered in 2017, was a breakthrough in our quest to understand the universe and the possibility of life beyond Earth. Situated just 40 light-years away from us, it's relatively close in astronomical terms. When you think of the vastness of space, 40 light-years might seem enormous. But in the grand scale of the universe, this system is practically our neighbor. What makes TRAPPIST-1 truly special is the sheer number of Earth-sized planets it contains. 7 to be exact. These planets are not just any regular planets. They are remarkably similar in size to our own home Earth. This resemblance in size leads scientists to believe that these planets could potentially have similar conditions to Earth, which opens up the possibilities of them hosting life. The most intriguing aspect of these 7 siblings is that 3 of them are comfortably nestled in what's known as the star's habitable zone. This is a region around a star where the conditions might just be right to support liquid water on the planet's surface. As we know, water is essential for life, at least life as we understand it. If there's liquid water, there might be an environment conducive to life. Furthermore, the star at the center of the TRAPPIST-1 system is a red dwarf. These types of stars are cooler and less luminous than our Sun. Because of this, the habitable zone where temperatures could allow for liquid water is closer to the star. This means that the planets in this zone, with their potential watery reservoirs, are in close proximity to their parent star, making them tantalizing targets for future observations. There's a significant effort in the scientific community to study these planets in detail. Using advanced telescopes and observational techniques, researchers hope to decipher the atmospheres of these planets. If they can determine the composition of these atmospheres, they could look for signs of life, or at least conditions favorable for life. The TRAPPIST-1 system, with its Earth-like planets and potential for water, remains a beacon of hope in the search for extraterrestrial life. Deep in the cosmos, in the vast expanse of our universe, there lies a phenomenon that has both baffled and excited astronomers for years. Fast radio bursts, commonly abbreviated as FRBs. First discovered in 2007, these are intense, millisecond-long spikes of radio energy that seem to come from very, very far away. and their origins remain one of the most captivating puzzles in modern astronomy. Imagine for a moment a lighthouse. It sends out a quick, powerful beam of light that sweeps across the landscape and then disappears, only to repeat again after a while. FRBs are somewhat similar in nature. They are these extremely short-lived yet incredibly powerful bursts of radio waves that, when first detected, left many experts scratching their heads. The distance from which these FRBs are coming from is astounding. Through various observations and calculations, scientists have determined that many of these signals are originating from galaxies millions to billions of light-years away. To put that into perspective, even the light from our closest neighboring galaxy, Andromeda, takes about 2.5 million years to reach us. That these brief signals from far-off galaxies manage to reach us is a testament to their immense energy and power. But what causes FRBs? That's where the plot thickens. There have been numerous theories. Some suggest that these could be the byproducts of massive cosmic events, like the collision of neutron stars or the eruption of supermassive black holes. Others even proposed more exotic theories, like signals sent by advanced alien civilizations trying to reach out to the cosmos. While the extraterrestrial hypothesis is undeniably thrilling, researchers tend to look for more conventional, natural explanations first. In recent times, some breakthroughs have been made. For instance, certain FRBs have been observed to repeat coming from the same location in the sky. This repeater behavior might provide clues about their origins. Are they from neutron stars in the throes of death? Or are they the result of some other high-energy astrophysical process? The hunt to uncover the mysteries of FRBs is ongoing, with newer telescopes and technologies paving the way for deeper insights. These enigmatic signals from the cosmos might not only teach us about the vast, intricate workings of the universe. Ever gaze up at the stars and think just what is out there? The vastness of space has always held mysteries that, despite our best efforts, continue to elude our understanding. Let's journey through some of the universe's most confounding, unexplained mysteries. The Boots Void, often referred to as the Great Nothing, stands as one of the largest and most mysterious voids in the universe. This immense expanse is situated in the Boots constellation, giving it its evocative name. While the scale of celestial objects can often be hard to grasp, the sheer size of this void is genuinely staggering. With a diameter of approximately 330 million light-years, the Boots Void's vastness is unparalleled. To help put this into perspective, you could fit our Milky Way galaxy into this space around 2,000 times. Even in the grand tapestry of the universe, where colossal galaxies and nebulae are commonplace, the Boots Void is an anomaly due to its sheer emptiness. When astronomers look at the universe, they generally see a web-like structure, where galaxies are linked in intricate patterns with vast spaces in between known as voids. These voids are not completely empty. Typically, they contain a few galaxies scattered within their bounds. However, what makes the Boots Void peculiar is the extreme scarcity of galaxies inside it. Considering its massive size, scientists would expect to find at least a few thousand galaxies within this region. Instead, to their astonishment, only about 60 galaxies have been detected so far. This means that less than 0.1% of the Boots Void's volume contains galaxies. The reason for such a sparse distribution is a question that has left many astronomers scratching their heads. While voids are formed as a result of the gravitational forces of matter pulling everything into dense regions, the Boots Void's barrenness doesn't fit typical models. Some theories speculate that the void is simply a massive region where conditions were never conducive to galaxy formation. Others propose that it might be the result of a significant cosmic event or anomaly that we have yet to understand. The discovery of the Boots Void was relatively recent in astronomical terms. Robert Kirshner and his team of astronomers first identified it in the mid-1980s. Using redshift surveys to study galactic distributions, they were taken aback when they encountered a region with a startling absence of galaxies. The vastness and emptiness of the Boots Void were so unexpected that the findings prompted multiple surveys to confirm its existence. The Boots Void's existence challenges our understanding of the universe's structure. Its sparse galaxy distribution and enormous size continue to be subjects of investigation and fascination for astronomers. Every new piece of data regarding this cosmic mystery pushes us to refine our models of the universe's evolution and structure, reminding us that the cosmos still holds many secrets waiting to be unveiled. Galaxies are mesmerizing structures, often likened to grand cosmic whirlpools, teeming with billions of stars, gas and dust. They dance to the rhythm of the universal forces at play. One would expect that the stars on the outskirts of a galaxy would orbit the galactic center more slowly than those closer in, much like the planets in our solar system. The inner planets like Mercury and Venus orbit the Sun faster than the outer ones, such as Neptune. This expected behavior is rooted in the laws of classical mechanics. However, the reality of galaxies presents a mystery that has puzzled astronomers for decades: the galaxy rotation problem. When astronomers began to measure the rotation curves of galaxies, they found something entirely unexpected. Using advanced techniques like Doppler shift observations, they found that stars situated in the outer regions of galaxies were moving at similar speeds to those near the center. Instead of rotation curves tapering off in the outer reaches, they remained surprisingly flat. This meant that stars on the periphery of galaxies were moving much faster than traditional physics would predict. So what could be causing these stars to defy expectations? The first indication of this problem emerged in the late 1970s when Vera Rubin, an astrophysicist, observed the rotation curves of spiral galaxies. Her observations showed that the speed of star rotations remained almost constant across galaxies. This was baffling because, according to the known laws of gravity and the observable matter within these galaxies, such rotation shouldn't be possible. One leading solution to the galaxy rotation problem has been the hypothesis of dark matter. While it sounds like something out of a science fiction novel, dark matter is a form of matter that doesn't emit, reflect, or absorb light. It doesn't interact with electromagnetic forces, which means it doesn't produce electromagnetic radiation, and as a result remains invisible. However, it does exert gravitational forces, and it's these forces that might be influencing the unexpected rotation curves. The idea is that a halo of this invisible dark matter surrounds galaxies, providing the extra gravitational pull required to keep the stars at the outskirts moving at the speeds they do. In fact, if the existence of dark matter were confirmed, it would account for approximately 85% of the total matter in the universe, making the cosmos as we know it the proverbial tip of the iceberg. Several experiments and observations have been set up globally to detect dark matter, either directly or indirectly. From deep underground labs trying to detect the elusive particles that dark matter might be made of, to powerful telescopes mapping the gravitational effects on light from distant galaxies, the hunt for dark matter is on. The galaxy rotation problem serves as a striking example of how the universe often throws curveballs our way, challenging our understanding and pushing us to seek answers beyond conventional knowledge. Whether the solution lies in dark matter or another, yet undiscovered phenomenon, this cosmic riddle remains one of the most tantalizing in the realm of astrophysics. In the grand tapestry of the cosmos, among stars, galaxies, and vast voids, there exists an intriguing anomaly that has left astronomers both curious and confounded: the Great Attractor. This entity, a region in space, exerts an immense gravitational force, tugging on not just our Milky Way, but also numerous other galaxies. But what makes it so compelling is the fact that its true nature remains largely unknown, concealed behind the expansive region known as the zone of avoidance. The discovery of the Great Attractor came about through observations of cosmic flow patterns. When astronomers studied the movement of galaxies, they expected a somewhat random distribution due to the expansion of the universe. Instead, they found a peculiar pattern. Many galaxies, including our very own Milky Way, were drifting in a specific direction at an abnormal speed, roughly 600 kilometers per second. This drift wasn't just a gentle cosmic dance, it was as if an unseen force was pulling these galaxies toward a specific point in space. Situated about 220 million light-years away from us, in the direction of the constellations Centaurus and Hydra, the Great Attractor is neither a single entity nor a particular point in space. Instead, it's a region packed with galaxies, forming a massive gravitational center. Given the vast distances and scale involved, pinpointing its exact nature is challenging. But one thing is clear: its gravitational influence is equivalent to a mass of tens of thousands of Milky Ways. What adds to the allure of the Great Attractor is its location behind the aforementioned zone of avoidance. This zone is filled with dense cosmic dust and gas, making it extremely hard for telescopes to peer through. thus masking a significant portion of the observable universe from our view. So while we can gauge the effects of the Great Attractor's gravitational pull, gaining a clear visual on what lies behind that dusty curtain has been a challenge. Using radio telescopes and X-ray observatories, scientists have managed to pierce through some of this obscurity. They've identified several clusters of galaxies in that region, including the Norma cluster, which is one of the most massive galaxy clusters known. Could the cumulative gravitational force of these clusters account for the pull we've labeled as the Great Attractor? As technology and observational methods improve, we're slowly gathering more pieces of this vast cosmic puzzle. The Large Synoptic Survey Telescope, for instance, promises future revelations about this area. For now, the Great Attractor serves as a testament to the universe's endless mysteries, reminding us that for every question we answer, countless others wait to be explored. When one pictures the universe, the imagery might be that of a vast, unending expanse dotted with stars, planets, galaxies, and cosmic phenomena. But behind this imagery lies a more intricate question about the very shape and geometry of our universe. Astronomers and cosmologists have wrestled with this question for decades. What is the shape of the universe? And intriguingly, most evidence points to the conclusion that the universe is flat. First and foremost, what does a flat universe even mean? It doesn't imply that the universe is a two-dimensional sheet. Instead, flat in this context refers to the geometry of space itself. In a flat universe, the rules of Euclidean geometry hold true on the largest cosmic scales. That means parallel lines will never meet. The interior angles of a triangle add up to 180 degrees and so on. One of the primary ways scientists have come to this flat universe conclusion is through the study of the cosmic microwave background radiation. The CMB is the afterglow of the Big Bang, a faint whisper of radiation that fills the universe. By studying the patterns within this radiation, scientists can infer the geometry of the universe. One of the key observations is the size of certain patterns or spots in the CMB. If the universe were curved like a sphere, these spots would appear larger, and if it were saddle-shaped, they'd appear smaller. Yet observations from satellites like the Wilkinson Microwave Anisotropy Probe and the Planck satellite have shown that these spots are just the size expected for a flat universe. Another compelling piece of evidence for a flat universe comes from the study of large cosmic structures like clusters of galaxies. Their distribution and the manner in which they bend light, gravitational lensing, are consistent with a universe where space is flat and not curved. But why should the universe be flat? The inflationary theory of the early universe provides a possible answer. According to this theory, in the first fleeting moments after the Big Bang, the universe underwent an incredibly rapid expansion, faster than the speed of light. This expansion stretched out any initial curvature the universe might have had, leading to a cosmos that appears flat across even the largest distances we can observe. It's worth noting that when we say the universe is flat, we're referring to the observable universe, the part of the cosmos we can currently see. What lies beyond that, or whether the universe might curve on scales even grander than we can currently fathom, remains one of the big open questions in cosmology. In essence, the concept of a flat universe challenges our everyday understanding and introduces a fascinating perspective on the vastness of the cosmos. While our observations currently support the idea of flatness, the universe has always been full of surprises. In our cosmic neighborhood, the term exoplanet has always stirred excitement and intrigue. These are planets beyond our solar system, orbiting stars other than our Sun. But while many of us have become accustomed to hearing about Earth-like planets or gas giants similar to Jupiter, the universe, in its ever-expanding mystery, has revealed a new type of exoplanet, the hycean planet. The name hycean might sound futuristic, but it's derived from the characteristics these planets exhibit. They're worlds larger than Earth, but noticeably smaller than Neptune, kind of like a middle ground in terms of size. What truly makes them stand out, however, is their environment. Enveloping these planets are vast global oceans, not mere pockets of water, but entire worlds covered in it. But as you might guess, these aren't serene beachfront properties. The oceans of hycean planets are beneath atmospheres heavily dominated by hydrogen. While hydrogen-rich atmospheres aren't unique in the grand scale of the universe, the combination of this thick, hydrogen-rich blanket with a water-laden world below is what makes the hycean category so fascinating. Essentially, the presence of such a substantial hydrogen atmosphere indicates a very different evolutionary history for these planets compared to Earth or even Neptune-like worlds. The discovery of this new class of exoplanets isn't just an academic exercise. It represents a paradigm shift in how we view our universe and understand the possibilities within it. Traditionally, the search for life and habitable conditions beyond Earth was fixated on planets that shared Earth's characteristics. But the emergence of the hycean category has broadened that scope, allowing scientists to look at potential life-bearing worlds through a new lens and redefining what we consider as habitable. When it comes to understanding habitability, it's human nature to lean into what's familiar. Traditionally, the search for extraterrestrial life or environments suitable for life has revolved around planets that resemble Earth. The Goldilocks zone, where conditions are neither too hot nor too cold for liquid water to exist, has been our guiding light. But the universe, with its vast and diverse wonders, doesn't always conform to our Earth-centric models. Enter the hycean planets. These unique celestial bodies challenge the conventional norms of habitability. Yes, they possess vast oceans, a tantalizing hint at the possibility of life. Yet the environment on these planets is radically different from what we'd consider comfortable. With their thick, hydrogen-rich atmospheres, conditions on hycean planets would be extreme by our standards. Immense pressure from the dense atmosphere, combined with possibly scorching temperatures, creates an environment that at first glance might seem inhospitable. However, it's precisely these extreme conditions that could harbor life forms very different from those we know. Scientists speculate that these worlds could have hotspots, regions within their oceans where temperatures and pressures reach a balance, potentially suitable for some form of life. Picture this: microbial life forms, or even more complex organisms adapted to their high-pressure, hydrogen-rich environment, thriving deep within the vast oceans of a hycean planet. Interestingly, the abundant hydrogen atmosphere could also play a pivotal role in supporting life. Hydrogen can trap heat, creating a greenhouse effect. This in turn could warm up the oceans below, regardless of the planet's distance from its parent star. As a result, even planets located outside the traditional habitable zone might still provide warm aquatic environments, thanks to this hydrogen-induced warming. It's a revelation that forces us to think outside our terrestrial box. For in the vastness of space, life might not always dance to the familiar rhythms of Earth, but could be swaying to the unique cosmic beats of worlds like hycean planets. At the core of the astronomical community's fascination with hycean planets is their distinctive set of characteristics, setting them apart from previously categorized exoplanets. Let's delve deep into what really makes these celestial bodies stand out. First and foremost, the name hycean is derived from two predominant features: hydrogen and oceanic. The combination of these two elements encapsulates the essence of these planets. While many planets possess oceans or hydrogen-rich atmospheres, it's the interplay between the two that defines hycean worlds. These planets are primarily water worlds. Unlike Earth, where continents punctuate vast oceans, the surface of a hycean planet is believed to be almost entirely submerged in water. This results in a deep global ocean, far more expansive than anything we have on our home planet. Imagine a boundless expanse of water, where the horizon melds seamlessly with the sky, uninterrupted by landforms. But it's not just the endless oceans that make hycean planets unique. It's also their thick atmospheres, predominantly composed of hydrogen. This dense, hydrogen-rich atmosphere contrasts with the nitrogen and oxygen-rich one we breathe on Earth. A hydrogen-dominated environment brings its own set of dynamic interactions, particularly when combined with the presence of vast oceans. Moreover, the atmospheric conditions on hycean planets contribute to another of their hallmark features, the greenhouse effect. The thick hydrogen atmosphere acts as an insulating blanket, trapping heat and warming the planet's surface. This could potentially maintain the temperature of the oceans at a level conducive to life, even if the planet orbits its star at a distance traditionally considered too cold for life as we know it. Another intriguing feature is the possible existence of a twilight zone, a layer within the deep ocean, where the pressure, temperature, and chemical conditions might be just right for life. While sunlight may not penetrate this deep, life could still thrive, powered by chemical energy from the planet's geothermal activity or other processes. All these characteristics paint a vivid picture of a world that is both alien and familiar. The mysteries of hycean planets beckon scientists and astronomers, reminding us that the universe is filled with wonders waiting to be discovered. In our ongoing quest to identify extraterrestrial life, hycean planets have emerged as compelling candidates. With their unique characteristics, these celestial bodies have offered fresh avenues for exploration and rejuvenated the hopes of many in the scientific community. To begin with, the very environment of hycean planets suggests a strong potential for life. These planets, with their vast oceans and hydrogen-rich atmospheres, present conditions that might be suitable for life forms distinct from those we're familiar with on Earth. The deep, expansive oceans hint at the possibility of a diverse marine ecosystem teeming with unknown organisms. Just as our oceans harbor everything from microscopic plankton to gargantuan whales, who's to say what marvels might exist in the depths of a hycean world? The prospect becomes even more tantalizing when we consider the Twilight Zone, a region deep within the hycean oceans. While initially it may seem counterintuitive to expect life in such an environment, devoid of sunlight, we must remember that life on Earth thrives in the most unexpected places. From hydrothermal vents in the deep ocean to acidic lakes, life has an uncanny ability to adapt and flourish. In the twilight zones of hycean planets, organisms might rely on chemical energy derived from the planet's geothermal activity or other intriguing processes rather than photosynthesis. Further bolstering the case for life on these planets is their greenhouse effect. The temperatures maintained by this effect could create environments suitable for biochemistry to take place, potentially allowing for the emergence and sustenance of life. Advances in technology have given researchers the tools to study these distant planets in greater detail. While currently, we can't definitively confirm the existence of life on hycean planets, the upcoming James Webb Space Telescope and other advanced observatories might soon provide clearer insights. They'll allow scientists to analyze the atmospheres of these exoplanets, searching for biomarkers, chemical signs of life. In a universe of infinite possibilities, the discovery of hycean planets has opened a new chapter in the story of our search for life beyond Earth. As we continue to unravel their mysteries, we might not only learn about these distant worlds, but also gain deeper insights into the very nature of life itself. The quest to find hycean planets has been fueled by curiosity and driven by technological advancements. While these planets as a category are relatively new to our exoplanet lexicon, some have already stood out, drawing considerable attention from astronomers and astrophysicists alike. One of the most discussed is K2-18b, located around 124 light-years from Earth. Orbiting a red dwarf star, this planet was initially identified by the Kepler Space Telescope. Later observations revealed the presence of water vapor in its atmosphere, making it one of the first exoplanets where water was confirmed. Given the nature of its atmosphere and its location within the habitable zone of its host star, where conditions might be just right for liquid water, K2-18b quickly became an intriguing candidate in the hunt for hycean worlds. Another notable mention is GJ-1214b, a planet orbiting the star Gliese 1214. Situated a mere 40 light-years away from us, this world is intriguing due to its thick atmosphere, which might contain large quantities of water. This could suggest vast oceanic depths, possibly with extreme conditions differing significantly from Earth's oceans. Beyond these, the 2I-700d planet has captured the imaginations of many. Discovered by NASA's TESS, also known as the Transiting Exoplanet Survey Satellite, it's the first Earth-sized planet in the habitable zone of a dwarf star. The potential for a hycean environment on TI-700d is promising, especially given its size and location relative to its star. Lastly, the Kepler-22b planet, located about 600 light-years from Earth, deserves mention. While it's larger than Earth, it orbits within the habitable zone of its star, Kepler-22. The conditions on this planet, particularly the possibility of it having a vast and deep ocean, make it an exciting candidate for the hycean category. It's essential to note that while these planets are promising, a lot remains unknown. The depth and extent of their oceans, the exact composition of their atmospheres, and other crucial details are still subjects of study and speculation. With every new discovery, however, we inch closer to understanding these enigmatic worlds and their potential for hosting life. And as always, I hope you enjoyed the video today. Thanks for watching.